certain parts, it deposits in certain parts, but the deposition is such that we don't really have, I don't know, maybe they are not that mixed, maybe they are mixed. If you are doing exploration in such areas, how do you think, where would you expect to find maybe sands which are good quality to constitute reservoirs?
Quite plain, well sorted.
How would you compare to the geometry of your channel? Any ideas? Ask it in a better way.
Well sorted sands.
I was asking that if you are doing your exploration in a field or in a basin where there has been a lot of, let's say, fluvial deposition. Most of the sediments are fluvial, and you have such meandering channels. Not what are they called? Meandering, yes. Or maybe braided ones. How do you go about? Do you go looking everywhere, or you have to be having in mind the geometry of what maybe the braided river system looks like, or meandering, so that you know that when you are looking for reservoir quality, maybe sands, these are the areas we can go to, and we can avoid these parts.
For example, now in a meander like this, it's eroding that side and depositing here. And so it's most likely depositing from this side of the meander. That's where I do looking for look at the sands. In case, because it may be a parallel river, and therefore the time this may be covered with the clays and get a good result. Because there you may not get a good result because there is no sedimentation, most of there is erosion from the outside bring them to the side.
But at one point, the meander was as far as still there. It was bending like that. So how would you go about with such dynamics? And as Dr. Semanda said, you can see the other wall. At one point, it was also cutting that far.
We also look for maybe the cut-off section, like there from maybe because there also now the export from would allow for clays to settle over those sands. Because it's no longer a river, now it's some stationary lake. Therefore, you have a good cut-off settled in that sense.
Maybe reservoir and a good cut-off on top of it.
Yeah, even just to add on what you said, like the clay is talking about, if it is deposited on top of the sands, since it has finer grains, maybe you can have formation of stratigraphic traps that can, if there is flow of petroleum to such a formation, you can have the oil grab there, stored there, and you can be able to tap it off.
Can I say something? Normally when a river is meandering like that, there are parts where the sediments will be eroded, and there are parts where sediments will be deposited. Like, that is not the best. If I have to draw it like this, here there will be erosion, and here there will be deposition.
No.
Like it's meandering.
The other way around.
It's the other way around, yeah. Oh, I was using a left hand anyway. So, probably me as an explorationist, I would look for the place where the sands were deposited most. Those are the reservoir existing, areas where I can find the reservoir. And yeah, generally I would look around there in case it's a large river. But for this case, there's no possibility for this case anymore. I can't. For this case, I would look around that side. Like where the meandering has taken place, I would look for such structures where there's deposition on the sand and leave alone the areas where there is erosion.
I think also one thing you have to know is that, maybe I start with the question. Why do you think we are having those walls and now the river is moving around here? Why are those walls now high up? What do you think has caused that?
I think it's because
The river
the volume of
Overloading that side.
At first it was eroding when it was a lot. Then at one point the volume of the water reduced, and then it could not be able to fill the other side, and maybe obstacles, maybe it changed course. Now it is moving through this side.
Yesterday when you, yes, okay.
since this place is tectonically active, I would presume there was some kind of up and down warping, because in low-lying areas and high-lying areas, like such borders, and the river can possibly flow here so easily than compared to those walls.
Yeah, so last time, yesterday I was saying that usually the water levels change. They may change because of tectonics or because of climate. And when climate changes, the water level, like the lake level, when it goes down, once the water level goes down, the river is going to cut through its own sediments. Because the part where it will now depositing the meandering part, it will start being even faster. So it will cut through its own sediments to deposit water into the lake. Now, it cuts even some of the sediments which were originally, which were deposited deeper into the lake. So in such a case, we find that very close to those areas, those active areas where we have water level drop, then the rise and all that, you will have sands being deposited when the level is dropped. Then when the water level rises, you will have the fine sediments now deposited again on top. So it will make the seal or maybe even the source rock. So, but it can also happen because of tectonics, because of subsidence of the lake. The water still will cut through its own sediments. So what we are having now is because the possibility is that the sea level, the water level dropped because the lake level originally covered a very big area. So now it has dropped, so it cuts through its own sediments. Yes.
Let me ask a question. Does this thing bring a big disadvantage? Like episode of you're depositing sands, you're depositing clays at one time. We do some lots of compartments, whereby you have like lots of compartments of oil, and you can't easily access all of them at the same time. So can it be like disadvantages of this kind of stratigraphic deposition?
Yeah, that's why it is very important to understand the deposition system in the area. You can have sands or reservoirs which we call stacked sands. So if they are stacked, it means you have a sand deposit here, another one on top, another one. You are able to drill. One well can pick all the oil from the different reservoirs. But you can have sand deposited here, another one there, another one there. These ones are not connected, so you have to produce using different wells. It's very expensive. So, and all that depends so much on the geologist who understands the deposition system there, and then the sort of reservoirs that you have in the area. Yeah. So if you don't understand, then either you are going to miss out on some of the reservoirs, or you may mislead the company, or at least you give them the right advice, then they take a decision whether to continue with the production and the development, or just forget about it and go away. Because that's more expensive.
So if we have meandering, we have looked at the meandering system. So where there is a bend like that, the deposition, we have a bar here. It goes somewhere, it turns. Instead, we have a bar here. There is a discontinuity. So what he's talking about, we have parts which can be good reservoirs, but they are disconnected from each other. Okay, and therefore, like Dr. Nagudi said, you can't produce from one well. Okay,
That's how 7.
Yeah, so that can happen with that. It can also happen with braided systems. Water flows, divides at certain points, leaves and deposits. Leaves, so you may have patches and patches of good quality maybe reservoirs, but then which might also end up maybe being good trapping systems if you have a carp, but then they are that's scattered. So if you understand your system very well, it means you're going to guide your team much better than one who doesn't know what they're talking about.
That's a question. I feel like, what if we could drill one well, then we patch down there, so we start, yeah, we go in different areas. This is only one well, have one well, and like, let me say we're having one over there, one over there, one that side. So just only drill one, and then we start direction of the river.
Yeah, all that depends on whether you understand what is there. Yeah, once you understand, then for you tell them the situation down there, then now those who are going to produce start planning, because you're a geologist, you're not the one going to plan, but you tell them this is what we have. Then they will see how to produce. But if you have them one after the other, then they will just yeah. So your advice, whatever step they have to take, will depend so much on your advice. You as a geologist who understands the system. That's why in your reports usually we insist on what was the environment of deposition or depositional environment. Or is it purely lacustrine? Is it purely fluvial? Is it both? No? Is it marine?
Because when you, for instance, you are hired by a company and you're doing such work, you're never going to depend on only the theory. The theory will only help you to interpret what you have, but the fields that you are dealing with are the guide. What you have found, you're only trying to use theory to understand. Now from the theory, oh, these are the characteristics of maybe the rocks, the sediments that you have. This must be maybe deltaic environment. So what do we expect? We expect maybe if it is this type of delta, it might be this. So you go on and on until you come down to the final analysis of what you have. Then you make the right decisions or right advice. That's why we are doing all this. It's a good thing you start like this and chart. It looks like a chart. You may never write down anything, but actually you can pull out something to write. And the quality also, maybe depending on the type of river system, its depositional characteristics. You may not have well-sorted, for instance, sands. You have mixtures, like you see here, maybe it's not a very good mixture. So they all determine the quality of reservoirs that you can have.